In this section, you will be learning about Java I/O, that is input output. So in this video, I will give you introduction. So we'll understand what does it mean by input output or why it is required, and we'll understand the basic concepts that are very important for getting the clear idea about input output. So I'll be starting from little basics, right? In this video, for giving introduction, I'll start from the little basics. So you focus on this one, don't miss this video, don't skip it. Because if you understand this one, then you can understand this topic very perfectly. So let us start. For explanation, I have a diagram here. This is CPU, central processing unit, that is processor. Then this is the main memory. Here I have written it. So this box shows main memory, represents main memory. I'll remove this one because there are too many things written on the board. If I remove it, it looks simple. Now you know this box is main memory. Now we know very well that the main memory is divided into 3 sections and used by programs. So a Java program will divide it like this. Here the Java program will be residing. We call it as method area, right? So I'll remove this Java program. This is sufficient. Now you can clearly see this is method area where the Java program resides. And this is stack. This will contain the local variables and the reference variables, so that will be present here. Then whatever the objects that we create using new operator, they will be created in heap. This is a heap area, right? So this is heap. I am showing it as an array object here. This is an array object. That is a heap. Now, these are the known things. Next thing. For any Java program, this method area and this stack together is the context of a program. That's its own region, its own territory, program's territory. So everything inside that is a part of a program, and all other things that you see here are external to the program, outside the program. Mostly we call them as resources. We already have learned about the resources. Yes, the same thing. So all other things are resources. Let me show you the resources. See, this is a monitor, display device, it's a resource. Keyboard, that is the input device, resource. File on a disk is a resource. It's external to the program, it's not a part of a program. And network, and behind the network there is some program on a remote machine. A program is running, a remote program. That is also a resource. And heap, that is outside the context of a program, that is also a resource. So all these things are resources. Now next important thing. A Java program interact with all these resources by transferring the data. So that is important here. The transfer of data is important here. So from some devices, from some resources, it may be taking input. That is from the keyboard, just the data goes into the program, right? And for some devices or for some resources, it will be sending the data out. So that is output. So whatever the program has to send, it will send it on the monitor and it will display. So input, output. And on a file, program may be sending the data or receiving the data also from a file. That is to and from file, data will be transferred. So this is input, output. Now this is a remote computer, and on that remote program is there. Our Java program is communicating through a network, via network. So it may be sending the data out, that is output, or taking the data in, that is input. So that's what is input, output. It means input, output of data. So that's what the topic is, input, output, right? Now, next we will learn about stream. What's a stream? Stream is flow of data. So the data may be flowing from a resource to a program, or data may be flowing from program to a resource. Like here, it may be flowing from program to a file or file to a program to a network or network to a program, or program to some array object in a heap, or from array object to the program. So stream is a flow of data. Now next thing is why it is called as stream. What sense it makes. So I'll give you an example. See, a flow of water is a stream. So from one container or from a tank to a vessel, if you are transferring water, you will take a pipe and put it in the vessel, Now open the tap, so the water flows from the tank into that vessel or a bucket. That is nothing but flow of water. It's a stream of water. We use the term. So same way, data is flowing. So stream is a general term. It can be flow of anything. So in Java programming, stream is a flow of data. So I have a picture here, detailed picture to show you. See, this is a keyboard. I have shown only few keys here. I am typing the keys. I have pressed A, then S, and then D, so that A and then S, then D is flowing through the cable of your keyboard and entering into your machine, and it is received by program. So as you go on typing, you are sending the stream of data, that is stream of characters or stream of bytes you are sending it. So if you are continuously typing it, so the continuously there is a flow of data. So that data can be treated as bytes or characters. So flow of data is like this. That's why it is called as stream. So that's it. I have finished explaining what is input output and what is stream. So we have completed these two things. IO means what and stream means. Now I will explain two important issues related to streams, and these issues are very important. You must understand their concept. So through this diagram it's easy to understand. So the first thing is buffer. Buffer. What is buffer? Where it is used? For explanation, I'll give an example. So in this one, the best suitable example is this one. This is a Java program and it is communicating with a remote computer, remote program. Data is being sent or received, whatever it may be. Now if the Java program is sending the data and it is on the receiving end, it has to receive the data. So the problem is whether the speed at which this Java program or this computer is sending the data and that computer is receiving the data, is it matching? The speed is same. Why we need to know about speed? So for that I'll give you an example. See, I have a bucket full of playing balls or tennis balls are there. I'm going to throw it on you and you have to catch them. So I am Java program and you are a remote computer. I am sending you stream of balls. I am going on throwing balls, right, one by one. So at what speed I am throwing, at the same speed you have to catch them. If your speed is different, if I am faster, you will drop the balls. Now, one more situation. If my speed is slow, then your time is wasted. Slowly I am picking up a ball and I am throwing it, and you are, by that time you are ready to catch it. So you are simply wasting time in preparing yourself to catch. So either way, if I am faster, then it's a problem. If I am slower, then also it's a problem. So there is no match in the speed. If there is no match in the speed, then what we need some buffer. We need some buffer. Now same way, if this Java program is very fast and it is sending the data with a higher rate, then for that Java program to read it, if it is slow, then we need something in between, that is buffer. So this Java program will drop the data in the buffer and it will finish its work soon. And slowly that program will be reading the data from here. So buffer is a memory object which is used for holding the data for some time to bring in the compatibility between the devices. So if one is faster, one is slower, but the entire data should be received there or reached there, so we will put them in the buffer. So this Java program can put it inside the buffer and slowly that program will be consuming it. Same way, if that program is sending the data here, then this program, if it is faster, so it will do its own work and that program will fill this buffer. Once it is filled, it will start consuming. So this we see mostly when we are watching videos online. If you watch a video, then it will first start buffering. So once it gets the sufficient amount of video, it will start playing. So till then it will be getting the video, part of a video, and it will put them in the buffer. So as the video is playing, already this buffer is getting filled. Because the rate at which the video is coming from there and the rate at which it is played on your device, this speed is different. That's why buffering is needed. So this is the best example about the video, buffering of video. So buffer is very important thing for transferring the data. If there is a incompatibility of speed in between the devices, yes. So buffer is the very important element of streams. So for handling the data in the file, now Java program will put everything inside this buffer and slowly it will get stored because the disk will be slower than the Java program or slower than your CPU. So slowly it stores the data, so the program can put the data in the buffer and it gets stored. Same way, this file data can be kept inside the buffer. Once it is filled, then Java program can consume the data. So instead of waiting for the disk to send the data byte by byte, it can allow it to store it in the buffer, and then when it is filled, Java program can take the data. Now one of the best example I will give you. See, here in India, everybody doesn't take bath in shower. They use a bucket full of water. If a person wants to take bath, he needs some quantity of water, right? He will open the tap and he will not start taking bath. He will allow that bucket to fill. Once it is filled sufficient and he can start taking bath, then it may not be completely filled, right? So up to some level he will wait, then he will start taking bath and that bucket will getting filled and he will be taking bath simultaneously. So this is what happens. So that bucket is nothing but a buffer. Because we can't take a bath in a tap water, we can take it in shower, but not in tap water. So we buffer it in a bucket and then we take bath. So that's what the same concept is buffer here. Same way it is used, it's like a bucket. So that's all. This was the important issue in Streams. We use buffer at many places. Now the next important thing, how the data flows in and out. This is very important. Listen carefully. Suppose I have a string, the name of a person, and the name of a person is John. This is there with Java program and it has to send it to a file. Then how this will be sent? Complete string is not sent. J separate, O separate, H separate, N separate. So byte by byte data is sent on the file. Not just file anywhere. I am taking an example of file. So if you have an object or data which is collection of characters or collection of anything, then the complete data is not sent. It is broken into bytes and sent. It's broken into byte. Now whether you call those bytes as bytes or characters, that's up to you. So it is broken into pieces and sent. Suppose you have some number. Let us say this is the name of a student and his roll number is 126. Then 126 will not come as a single number, 1 separate, 2 separate, 6 separate. So it's broken into bytes and sent. So this is very important thing. So data is sent in the form of bytes, right? Byte by byte. It's not sent as a big chunk, as a single unit. But that chunk is broken into bytes and data flows in the form of bytes, or you can say characters also. That's it. This is the important thing, that data is sent in terms of bytes. And if at all you want to send this thing as a single value or this as a single value, how it is done, we will see it afterwards. But basic thing is it is broken into bytes and sent. Now the last thing in the video is what Java provides for streams. So Java have lots of built-in classes for stream, and learning IO stream in Java is nothing but learning about those classes. Nothing but learning about the classes. Now this, you know the concepts, the mechanism, everything you know. Now you have to learn the classes and how to use them, where to use them. That's it. So broadly, Java provides two types of stream classes. One is byte stream classes. As I said, that data is flown like a bytes, collection of bytes, stream of bytes. So that's why byte stream classes. And Java also supports character stream classes. What is the difference? See, byte means just one byte, but in Java, character takes 2 bytes, right? That's the difference. So 2 bytes. So whether it's a byte or a character, it's the same thing. If you want to read it as a character, you can read it, but the data will be flowing in terms of bytes only. So Java supports Unicode. That is the reason it has separate set of classes for character stream. And under this is for input stream. That is whatever is coming inside Java program. If I stand here in Java program, now whatever is coming in is the input stream. Then output stream, whatever is going out from Java program is output stream. That is for byte stream. Same way for character stream, the similar one, just like input stream, this class is called as reader class, and for output stream, the class is called as writer class. And the next video, I will discuss about these classes, the details about the classes. And if you know about these two classes, this is sufficient for streams. And you can automatically understand how to use all other classes because I have given you sufficient concepts here. You can easily use them. So that's all in this video.